Alright, so for this video lesson, we're in section 1, activity 3. This is extreme values of distances and times. This is the topic that I mentioned in our meeting on Monday. So again, I think with these max-min problems and the word problems, the hardest part is going to be setting them up. Once we have it set up, you guys have really good calculus skills. So once we're past the setting up point, I think we're going to be good. Okay? So let's get into this. So just a note here. So another application of calculus is describing the positions and paths of moving objects. Okay? And the best way to deal with these problems is to organize them on a coordinate grid and describe the position of the object with respect to the origin. Okay, so this is the kind of tricky word problem house. There's a house here. This was the tricky word problem that I was talking about. Okay, so again, let's set up a grid, and we have two planes here. Okay, so we have a plane flying west at 200 kilometers per hour. Okay, and it passes a house 10 minutes before another plane flying south at 300 kilometers per hour passes the same house. So let's make our house will be green, will be the origin. Okay, and plane 1 is going to be blue. Okay, plane 1 is going to be the one flying west. Okay, so we have a house flying. It passes the house and it continues to move, right? 10 minutes later, or 10 minutes after the blue plane has passed the green house, then the plane flying south, so that's going to be my red plane, passes over the same house, okay? So think of the plane flying west, so it's just cruising, right? I hope you can hear my sound effects, right? And then 10 minutes passes. Okay, so this plane continues to fly. And then 10 minutes later, a plane flying south passes over the same house. Okay, so 10 minutes later, and then that passes the same house. Okay, so that's what it kind of looks like. So our blue plane flying west. So as we're setting up this problem, so assuming both planes are at the same altitude, at what time is the distance between them a minimum? Okay, so this is going to be really hard to do with with only one hand at a time, right? But soon as we move to the left, right, at time 0, where plane flying south is going to be, it's going to be north of that green house, right? Because it passes it 10 minutes later. Okay, so it's going to be north of that house. So let's think about this, and let's use our physics skills to kind of help us find some distances, okay? So 10 minutes, so 10 minutes divided by 60 minutes gives us 0.16 repeating of an hour. Okay, so for our blue plane there, so within that 0.16 of an hour, if it's flying at 200 kilometers per hour, we know that it is 33.3 kilometers past. It's past the greenhouse when the red plane passes the greenhouse. Right? Remember the blue plane passed the greenhouse first. Okay? Now, we know that within that 10-minute window, 0.16 repeating of an hour. If our plane flies at 300 kilometers per hour, this tells us that if it takes 10 minutes to pass over that house, this tells us it is 50 kilometers north of the house, so it starts right here. So when the blue plane passes the green dot, our red plane is 50 kilometers north of that house. Okay? So one thing I want you to take into consideration is that we are essentially looking for the shortest distance between the blue and the red plane, right? So right at time equals, like, as soon as that blue plane passes the green house, we're 50 kilometers away. So our distance would just be a straight line down, right? But as that blue plane continues to move, so is the red plane. Okay, so we're just trying to find the rate of change, which gives us the smallest distance there. Okay, and again, we know that initially that plane flying south, the red plane, is 50 kilometers north of our greenhouse. Okay, now we know this information based on those 10 minutes, but let's go ahead and set up a general expression after any time t. Okay, so after time t, our blue plane is going to move at 200 times t. If we wanted to find the distance, right, it would just be the 200 kilometers per hour times how long it has been flying for. Now for plane 2, okay, to find the distance of plane 2, it's starting at 50 kilometers above, sorry, I should use red for plane 2. Okay, it starts 50 kilometers above the house, which is our origin. So it's 50 minus the rate at which it moves, so 300 t. Okay, so for after general time t, P1 will move 200 times t, and P2 will have moved 50 minus 300 t. Okay, so now that we've set up, or we've kind of established the distances for our planes, let's go ahead and draw a new grid with our time t. Okay, this is our general time t. So I'm going to draw a new grid here. Okay, and we know, so let's say that our blue guy starts right at the origin now, okay? So this is our time 0, right when the blue plane passes over the house. Okay, so the distance in which the blue plane can fly during time t is 200 t. And remember that when the blue plane passes the house, our red plane is 50 kilometers north of the origin, okay? So, and as that plane is going to move towards the house, it is going to move at the rate of 300 t. Okay, so to find that whole distance for our plane headed south, it is going to be 50 kilometers, which is our starting point when the blue plane passes the house, minus 300 t. Okay, so that is going to describe the location of the red plane with respect to the house, which is our origin. Okay. So that's what we have so far, and again, we're trying to find the minimum distance between the two planes. Okay, so if it is somewhere here, if it is somewhere there, if it is somewhere over there, right? We're just trying to find the shortest distance between the two planes, and this can go back prior to those 10 seconds which elapsed after it passed the house. Okay? Okay, so to find the minimum distance between here, we're going to call this z. Our hypotenuse is going to be z. Okay? Hopefully you are looking at this and it kind of looks like a right triangle. It is indeed a right triangle, right? This is a Cartesian plane. So the x and the y-axis will form a right angle. If it's a right angle, we have a right angle triangle, and we can use our Pythagorean theorem for that. Yay. Okay, so my z, which is my hypotenuse, so z squared is equal to a squared plus b squared. So what is your P2 value, or my red value? So it'll be 50 minus 300t plus the distance expression for plane 1, which is just going to be 200t. And don't forget to square these, because this is the Pythagorean theorem, right? Okay, so let's go ahead and expand our brackets. So z squared becomes, and these are all z's, okay? Not to be confused with the 2. I know it's not the best variable. Maybe you want to change your variable to not be z. Okay, but z squared is equal to, so 50 minus 300t expanded. And that is going to be plus 200t multiplied by itself, so that will give us 40,000 t squared. Okay, let's finish expanding our red brackets. So 50 times 50 is 2,500 minus 15,000t twice, so minus 30,000t. And lastly, we're going to get plus 90,000 t squared. And we have our plus 40,000 t squared. Okay, so let's clean this up a little bit. Combine our like terms and rearrange this. So z squared is equal to 40,000 t squared. Uh, 40,000 t squared. Sorry, that should be 130,000 t squared. My apologies. Minus 30,000 t plus 2,500. Okay, so at this point here, we have a simplified function. So now that it's written like this, we want to find z minimum. And we can find this when the derivative of z with respect to t, because t is our variable here, is equal to 0. So let's take the derivative of both sides here. Now remember, anytime that you're going to derive a variable here, you need to indicate that you have indeed taken the derivative of that, right? So the derivative of z squared is going to be 2z multiplied by the derivative of z with respect to t is equal to the derivative of 130,000 t squared will be 260,000 t minus 30,000, and then 2,500 derives to nothing. Okay, so let's solve this for our derivative. So let's divide both sides by 2z. That will cancel. Okay, now I have dz over dt, or z prime, okay, is equal to 130,000 t minus 15,000 over z. Okay, now let's solve for when our z prime is equal to 0. So 0. Oops. 0 is equal to 130,000 t minus 15,000 divided by z. Okay, we'll multiply both sides by z. That cancels. That is just 0, right? We will add 15,000 to both sides. That cancels. Now we're left with 15,000 is equal to 130,000 t. Now we'll lastly divide by 130,000. And 15,000 divided by 130,000 will give me a t equal to 6.92 minutes. Okay, so now we know the time at which the distance between the two planes is a minimum, and we want to know the distance to the nearest hundredth. Okay, so we know that it's been flying for 6.92 minutes. When you divided this, I missed a did a step. Excuse me. So this will actually tell us in hours, so 0.115 hours. And then if you multiply that by 60, you'll get 6.92 minutes. Okay? So we know that t is equal to 0.115. So let's go ahead and put those back into these expressions right here to find the distance at which both of those planes had traveled. Okay, so for my plane headed west, so P1, it is 200 multiplied by t, which is 0.115 hours. And of course that 200 is kilometers per hour. So we get a value 23.08 kilometers. Okay, so that 0.115 is rounded, and I'm multiplying that by 200, and that's how I get my 23.08. Okay, and of course I'm not rounding my intermediates, but I do not want to include all of my decimal places here. Okay, so plane 1 has moved 23.08 kilometers from the beginning, right, from a time equals 0. And our plane 2 is going to be 300 multiplied by 0.115. And that tells us it has a distance, so P2 is not 300 multiplied by t, it is 50, remember it was 50 kilometers north to beginning, minus 300 t. 50 minus 300 times 0.115, and that gives us a distance for plane 2 of 15.38 kilometers. Now again, we want to find the distance between those planes, so this is our last step here. We need to find the hypotenuse between the two, right? So we know this one plane has moved 23.08 kilometers west, and this other plane has moved 15.38 kilometers south. So we want to find our z here. Okay, so one more Pythagorean theorem. So z is equal to the square root of a squared plus b squared, so 15.38 squared plus 23.08 squared. Okay, punch those into your calculator and we'll get a z value of 27.73 kilometers. Okay, so we know after 6.2 minutes of flying that these two planes are going to be 27.73 kilometers in separation. And this is the shortest distance between those two planes as they are flying. All right, so for our second example for today, we have two yachts which are off of a straight shoreline. Okay, so I'm going to go ahead and draw our shoreline here. And we know that yacht A yacht Acura is 4 kilometers off of the straight shoreline. That's going to be my A. 4 kilometers there. Okay, and then we also have our yacht B. I'm just going to move this down a little bit. Okay, and then we have our yacht B, which is 9 kilometers down the coast and 8 kilometers off the shore. Okay, and these are 9 kilometers apart. Okay, so that's our setup. A boat from yacht A is to bring a passenger to the beach and then to proceed to yacht B to pick up another passenger. Okay, so we're going from A to the shoreline and then over to B. So the question is asking us at what point along the shore should the first passenger be dropped off in order to minimize the distance. Okay, so what is this value from here to here to minimize that distance? I'm going to call that Z again. So if this region there is going to be Z, then this remaining region here is going to be 9 minus Z. Okay? My x value is going to be the hypotenuse here. Okay, that is going to be kind of the distance at which A traveled. And then my other hypotenuse is going to be my y value here. Okay? So the distance that this boat is going to travel goes from A to the shore to B. So the distance in total is going to equal x plus y. Okay? Now, again, we have two right-angled triangles here. So we can apply Pythagorean theorem to help us solve. So let's do x first. Okay? So x is a hypotenuse. So x squared is equal to 4 squared, which is my one side length, plus my other side length, which is z squared. Okay, now let's solve for x. So we'll take the square root of each side. So x is equal to the square root of 4 squared, which is 16, plus z squared. Okay, and don't simplify that any further, okay, because it's going to help us take the derivative of this a little bit later on, okay? So we've just solved for our x. Now let's solve for our y. So y is our hypotenuse, so y squared is equal to the square root of 8 squared plus 9 minus z squared. Okay, so let's go ahead and simplify this. And sorry, I put the square root on there a little too early. I got a little excited, I'm sorry. Okay, so y squared is equal to 8 squared plus 9 minus z squared. And let's go ahead and expand these, okay? So y squared is equal to 64, 9 minus z, multiplied by 9 minus z, so 64 plus 81 minus 9z minus another 9z, so minus 18z plus z squared. Okay, we can simplify this a little bit. So we get y squared is equal to 64 plus 81 is 145. So I'm going to leave that at the back. So z squared minus 18z plus 145. And lastly, let's solve for y. Z squared minus 18z plus 145. Okay, so now that we have solved, we've set up these two equations in terms of x and y. Now we can substitute these in to our distance formula that we have at the top here, okay? So distance is going to be x plus y. My x is root 16 plus z squared. And my y is root z squared minus 18z plus 145. Okay? Now, hopefully you're recognizing we can rewrite these square roots as exponents instead. So distance is equal to 16 plus z squared to the 1/2 plus z squared minus 18z plus 145 squared. Or to the 1/2, sorry. To the 1/2. Good. Okay, so now that we're at this point, let's go ahead and take the derivative of this. So d prime is equal to, and we're going to have to apply the chain rule here. So we're going to have 1 over 2 comes out front, multiplied by 16 plus z squared, minus 1/2, multiplied by the derivative of what's inside the brackets. So 16 derives to 0, and z squared derives to 2z. Okay, and then we're going to add our second term to that. So, and again, we're going to take the derivative here. So 1/2 comes out front, and then we're left with z squared minus 18z plus 145 to the exponent negative 1 over 2, multiplied by the derivative of what is inside those brackets. So we will get 2z minus 18. Okay, so we gotta clean this up and simplify this a little bit. Okay, first thing I'm gonna do is factor out a 2 from this z minus 18. So it becomes z minus 9. Now I'm going to clean this up. So 2 and 1/2 will cancel. And my 2 in front of the z and the 1/2 again will cancel. Okay, so let's rewrite this. So we have 16 plus z squared to the negative 1 over 2 multiplied by z plus z squared minus 18z plus 145 to the negative 1 over 2 multiplied by, no, that is 2 multiplied by z minus 9, and then we're left with just our z minus 9 here. Okay, now to find a max or a min, this question is a minimum, so we want to set, and even if it was a max, we would still set it equal to 0. So let's go ahead and do that. And I'm also going to rewrite this so we have our negative exponents in the bottom. Okay, so 0 is equal to z divided by 16 plus z squared to the 1/2 plus z minus 9 divided by z squared minus 18z plus 145. Plus 145. Oh crap. 145. There we go. All right. So we're going to be solving for our z here, so we have to do our calc skills from previous courses. So let's subtract z over 16 plus z squared to the 1/2 from both sides. Those will cancel. And now I have negative z over 16 plus z squared to the 1/2 is equal to z minus 9 over z squared minus 18z plus 145. Okay, now we have square roots in the bottom, so let's get rid of those, okay? So we will multiply both sides by the denominators in each of our functions here, okay? So I'm going to multiply this side by 16 plus z squared, the 1/2, multiplied by z squared minus 18z plus 145 to the 1/2. So these will cancel. Okay, and then I'm going to do the same thing over here. I'm multiplying it by 16 plus z squared to the 1/2 times z squared minus 18z plus 145 to the 1/2. So these will cancel over here. And then what will I be left with? Okay, so we will have negative z multiplied by z squared minus 18z plus 145 to the 1/2 is equal to our z minus 9 multiplied by 16 plus z squared to the 1/2. Okay? So what are we going to do here? Let's square everything on both sides. Okay, so my square, or my 1 over 2 exponent and my 2 exponents cancel. So this will leave me with z squared. So negative z times negative z is z squared bracket z squared minus 18z plus 145 is equal to z minus 9 squared, 16 plus z squared. Okay, let's go ahead and distribute this in. And we're also going to expand this. Okay, so we will be left with, on the left side, we will have z to the 4 minus 18 z to the 3 plus 145 z to the squared is equal to z minus 9 expanded becomes z squared minus 18z plus 81. And that is still multiplied by 16 plus z squared. Okay, and again, let's distribute this into our brackets. So we will be left with 16 z squared plus z to the 4 minus 288z minus 18z cubed plus 1296 minus 81z squared. Okay, so let's clean this up. Okay? Remember, we're just looking for one z here. So I'm going to subtract z to the 4 over here. Subtract z to the 4 here. Those cancel. I will add 18z cubed over here. And add 18z cubed over here. Those cancel. I will subtract 145 z squared. And subtract 145. Let's go over there. That will cancel. And so let's go ahead and simplify this. Okay, so we have a z squared here. And we have a z squared over here. So our final z squared, we're going to have, so now this whole side is equal to 0, is equal to negative 48 z squared minus 288 z plus 1296. We're getting there. Okay, we're still solving for z, right? So let's factor out a negative 48. So z squared plus 6z minus 27. Now we need to factor this. So what gives us a product of negative 27, but a sum of positive 6? That will be positive 9 and negative 3. Okay, so we can set these equal to 0. So when z is equal to negative 9 or positive 3, we will get our answer, right? We don't want a negative value for distance, so we can get rid of that. So we know that our z value is equal to 3. So what does that mean? What did we even calculate? What is our z value? So our z value is right here, right? So we know that z is going to be 3 centimeters, so maybe something like that, or 3 kilometers. and that means this remaining distance must be 6 kilometers. Okay? So what point should the first passenger be dropped off? Z is equal to 3 kilometers. All right. So hopefully that was a good review for our just general calculus and simplifying skills. And if you have any questions, please don't hesitate to ask. And yeah, I hope you enjoyed this lesson, and we'll see you soon.